Hey everybody, Dave Lindbergh with another episode THD Podcast in Hong Kong. Today, we're hosting some guys in the States called Trillbit. They're using what I understand as either some kind of sub or hypersonic audio and some encoding with that to communicate data using non-audible audio paths. So we're going to find out if I understand what I've researched prior to that. But before I forget, let's not discount. We have our Alti, our sponsor, the Audio Loudspeaker Technology International, a great networking organization for people involved in the audio and manufacturing industry. So please take a look at that. But without delay, let's say hello to everybody. So Simon Weston in Japan, how are you doing this morning?
Very well, thanks, Dave. Morning to you, evening to the guys.
All right, great. And so we have Robert Poor, the president of Trillbit. Good evening, Robert.
Good morning, good evening.
Yeah, and Bhaskar Deo, the founder and CEO of Trillbit. How are you doing?
Hi, good morning.
All right, great. So yeah, Robert, maybe you give us a bit of a history or a prologue into who Trillbit is, and let's take it from there.
Just by way of orientation, Trillbit develops and markets what we call an authentication toolkit. And it's designed specifically for smart devices or IoT devices, in particular, voice-enabled smart devices. And I'll explain why that's important. But let me back up a little bit. Back in the early 2000s, I co-founded a company called Ember. And Ember was one of the very first companies to make IoT chips, even before it was called IoT. And we helped push the Zigbee standard, which became popular for a long time. And I gotta say, it was popular pretty much until Wi-Fi got cheap enough and low power enough to become a viable alternative. But it really did help kick off the whole IoT world. I mentioned specifically that we're focused on voice-enabled smart devices, and that's for a couple of good reasons. First off, voice-enabled stuff is the future. And the way I like to describe that is, a decade ago, we used web browsers as our primary way to communicate with the internet. More recently, we use smartphones as our primary way of communicating with the internet. You know, and I know, in the near future, voice is going to be the primary way of interacting with the internet. And we're already seeing the beginning of that. For example, with smart speakers, with all the services like Alexa, Google. And there's a reason for this. It's much more natural to say, Alexa, turn on my living room lights, than it is to pick up your smartphone, open an app, push a button to turn on the lights. And to bear this out, the estimates are that this year, 2022, there'll be 2 billion voice-enabled smart devices sold. And that's a quarter of the world population. Now, there's two problems still remaining with this stuff. I don't know if you've got any smart devices at your house. Setup is still a pain. A smart device isn't smart until it's on the internet. And so it sort of begs the question, how do you get it on the internet if it doesn't have a smart interface yet? This is one place where Trillbit comes in. And the other place where Trillbit plays an important role is authentication. Just imagine for a moment if none of the transactions you did were secure, right? This is a big problem. Trillbit uses ultrasonic data. Any trusted device with a speaker communicating with any device with a microphone and an internet connection can be turned into a secure method for transactions. So that's why I say we are a authentication company. We make it so you can authenticate inexpensive consumer level devices with secure transactions.
Okay.
So far, so good? Great. And
yeah. Okay. Well, that authentication, are we talking about like using like your actual voice for like instead of thumbprints and things like this?
Brilliant question. I'll toss that over to Bhaskar to answer.
Okay.
So essentially, I don't want to dish out voice, but one of the issues with voice is it's really easy, or it's getting easier using deepfake to circumvent any kind of like voice authentication. So we are not really voice. We send an actual data, and that is a real-time anti-spoof and encrypted data stream between any device on one side, which has a speaker, and any device on the other side, which may have a microphone. So it's a real-time, and we support a lot of host of encryption schemes and different authentication protocol. Also, one of the examples is, for example, FIDO. So it's not voice recognition. It's a real data stream that you would have over any other channel.
Okay. Yeah. All right. So then the transmit device is using a speaker, and there's something and it's non-audible.
Receive device.
And can you, well, I guess maybe you'll get into this later. I don't want to spoil the introduction for Robert, but are you able to use the same speaker and in parallel transmit data and audio on the same speaker, so we have redundancy in the hardware?
Yes, we can send it along with audio as well. So because that spectrum generally which we are using is above the human hearing range, so between 18 to 21 kilohertz, and that's mostly not used. So that's what we're using for transmission. So it can go concurrent with the other things which the speaker is being used for.
Okay.
Is there actually two technologies here? One is data over ultrasound, and another one is encryption, or is it really the encryption is an existing technology that's being applied to this data over sound?
Yeah. So the encryption schemes are the standard encryption schemes. Like what is used by, for example, the DEFL key exchange, what FIDO uses, like a PKI, like private keys and public keys. So those are all standard, and we basically, our product is implementing these authentication protocol using data over sound. So as a product, they include the technology, which is data over sound, and these encryption schemes, which are widely accepted or widely standardized.
I mentioned early on that Trillbit offers an authentication toolkit, and that's really the way to think of it. We use data over sound as the primary transmission medium, but for the developers, our SDK offers different kinds of encryption, different kinds of authentication, things for ease of setup, whatever it is that's appropriate for your own particular application.
And could I just ask, what's the significance of authentication in terms of data over sound? Why just authentication, I guess?
Oh, it's not just authentication, right? But for example, it could be, let me give one use case that's going on right now. In India, a company called Cello is using Trillbit's technology for payment systems for buses. And the way it works is you get your cell phone out, you open up an app, you walk onto the bus, and your cell phone, the speaker in your smartphone communicates with a little kiosk in the front of the bus. It authenticates who you are, does the full handshake, two-way transaction, your fare is paid, and you walk on. What's significant about it is, first off, Trillbit's technology is working in 300 different makes and models of mobile phones now. And they're not all Android and Apple phones. These are from all over the world. So they don't all have NFC. They don't all have a lot of processing power. But for our technical folks in the audience, the computational footprint for audio is really compact, and it's been designed to fit in consumer devices.
Right.
The second interesting thing is that this whole transaction, this two-way multi-factor transaction happens usually in about a second. And if you think about buses or buses anywhere really, it's probably the least controlled audio environment you could put yourself into. It's noisy, it's got a lot of stuff going on, right? Currently, Trillbit's technology is authenticating, 150,000 transactions a day? Is that about right, Bhaskar?
Yeah.
So it's thoroughly been proven out in the field to be robust even in nasty environments.
Right.
And as I said, that's just one of the use cases. There's another use case where an elevator company wants to have communication enabled from within the elevator, also known as a Faraday cage.
Yeah.
So you can't use your usual Wi-Fi, but ultrasonic audio is perfect there. So again,
There's how am I understanding this right then? So if you wanted to use, say, an RF system to do the same job, you would have to have first established like a Wi-Fi connection connected to the router or something like that. This means you just bypass all of that and you just have this direct data link.
Right. Right. And I have a slide which could show where we stand with respect to, other modalities of authentication, NFC being one of them, or voice authentication being another, for example.
Okay. Should we go to that, or Robert, did you want to cover off some more intro?
We can circle back.
Sure. Yeah, let's, we've mentioned it, so let's show it.
Yeah.
Essentially, if you look at authentication, especially authentication on devices that really do not have a user input interface, it's very difficult, right? Because if you don't have a user interface, how do you authenticate on those devices? And now that, voice control is being added to nearly every device. So everyone has interacted with, say, a smart camera, or a smart speaker. But now they are coming in all the TVs, all the fridges, washing machine, and even your coffee maker, right? And of course, they are even more proliferate in industrial IoT, for example, looking at device diagnostics to even doing predictive maintenance, for example. So while mic is being added to each of these devices, there is traditionally not another kind of authentication medium like a touch interface. So we solve both the problem of ease of setup for these devices as well as authentication using our technology called data over sound. So basically, any manufacturer of a device can add our SDK and give its users a seamless way to set up these devices and as well as authenticate, do any kind of authentication. So we are a software-only platform which can be integrated into any app, any web page, or any embedded device. The technology works in normal everyday devices. So a normal speaker and a normal microphone. And when I say like normal and everyday device, I don't mean like $500 phones. I mean $20 devices. We just have a speaker and a microphone would work with this. So here is a video. I don't know how it will come out, but let me show you. And this gives you like 2 examples of how it works, right? And a picture is worth 1,000 words. So hopefully this will this will give some more color on like how this would work. So generally, what we work on is we always need a trusted device, right? So a trusted device is basically the device which is doing the authentication. So in the bus authentication example, which Rob shared, it's basically your phone is your trusted device, right? So here is the same case where on the right, you'll see the phone as a trusted device. And on the left is basically a Chrome application. And we are trying to log into that Chrome application without doing any kind of a touch interface or any kind of a typing. And it gives you basically, it gives you that your trusted device, which here is a phone, is next to where you are trying to do a login. So it's a proof of presence.
With a single tap, we can log into any device. So on the left, we have the login page open on a Chrome, and on the right is the Trillbit Sound Authenticator. So it needs my fingerprint, which I will just give here, and then with a single tap, I'll be able to log into my device without the need for any kind of a typing or any kind of a touch interface.
So this was an example of logging into a device, but here device was already online. But what if the device is not online? How do you set up a device today which do not have a user interface or which do not have a touch interface on a network? And today it's like a 6-step process. So In the sixth step, you create like a hotspot, and then you try to connect to the device, and so on. And in the six-step process is not just a user inconvenience. There is data which shows that about 7 to 10% devices, IoT consumer devices, are returned because of setup issue, which is that people are not able to set it up and hence they return. So think about it. It's about 10% revenue leakage in $1 trillion industry. And here is our solution to that. So in this case, we are using Alexa as a trusted device, right? And there's Alexa skill, which is essentially what Alexa skill is doing is essentially transmitting the Wi-Fi credentials to this IoT device. And on the right is basically an IoT device. It could be any device. Here is an insert. Instead of this device, it could also be your phone. So a trusted device could be anything which you trust. It could be a smart speaker, it could be your phone, it could be your laptop.
Open Trill Setup.
Is your device in setup mode and nearby?
Yes.
Transmitting your encrypted Wi-Fi credentials over sound.
So now it's transmitting.
Mm.
And it takes like a second.
Right.
That's it.
And that's it. It connected.
So there's no need for an app. There's no need for a pre-setup. Yes, so.
In the ease of setup department, I wave this thing around as a prop because despite my best efforts, despite my advanced degree from a technical university, I have not been able to get this on the internet. But it makes a pretty good prop.
Right.
So ease of setup really does remain a big problem.
Yeah, no, it is. And just sorry to cut you off, Bhaskar, but that is a huge thing that people spend time on with their smart speaker or IoT devices. In product development, I mean specifically, is the user interface and how to make the setup process simplified. And so they even go so far, they add NFC and other hardware and add cost into the device to make it more simple, so they can just tap their phone on it and do that. So basically, yeah, you're just going to be reusing the hardware, and then this block of code just goes on to an existing processor with little kind of software footprint, is what you're telling us.
What's exciting to me is that the MEMS microphones that make this possible, those MEMS technology, are getting really inexpensive. They're available like popcorn. Knowles, who's one of the largest manufacturers, is making 2.5 billion of these devices in this year. And I'm especially excited that we ink to deal with them, where Trillbit's technology will become a checkbox in your procurement process. You can just add Trillbit's technology when you buy a Knowles microphone.
Wow.
And also, I think a lot of your audience would know about the company called Espressive. They make the ESP32. That's become the kind of dominant design for anyone who's building embedded devices, smart devices. It's a little early, so we can't talk about all the details, but we are in discussion with them about what it takes to put Trillbit's technology, again, just as an add-on when you buy an ESP32 system.
Yeah.
And between those two things, we have a pretty good fulcrum against which to push.
Yeah, no, I know the Expressive is popular in a lot of Alexa devices. And just a sidebar, if you have anybody there, we've been trying to talk to them on this podcast for some time, so we can talk offline, maybe an intro for us.
Sure.
But yeah, sorry. So keep going, please.
Yeah. So a few minutes ago, Simon asked about multi-factor authentication and what that might be like. Just one way to describe it is, how often have you opened up a banking app and it sends you a text code with a PIN that you have to type in? You are doing the multi-factor authentication. It's passing through you, the user, right? So the human looks at the numbers, takes the numbers, and puts them somewhere else. Imagine instead if that was just an ultrasonic link between two devices. It can happen very fast, very secure. You don't have to stare at the numbers and type them in, but it just automatically goes from your trusted device to whatever you're trying to authenticate. And So wherever you see yourself typing PIN numbers, transferring PIN numbers from one place to another, this is a place where authentication toolkits can come into play.
Very clear. Yeah, very clear.
Right. Great. So essentially, we have designed this to work for average normal IoT devices. It's completely cross-platform. So we have built the protocol from ground up. So it works exactly in the same way between Windows, iOS, Android, and embedded systems. It's much more secure than any other traditional method. However, it's at the same time, it's frictionless because you can make anything more secure by adding additional steps, right? And additional checks. But if it doesn't make life easy, then people will try to circumvent it. So if you think about it, the primary communication here still is happening over the normal channels, which is your Wi-Fi or say 4G or 5G and so on. But the authentication is happening over an ultrasonic or near ultrasonic link. So essentially, when you are decoupling your primary communication from the authentication, it gives you an additional security for the whole system, right? So that's inbuilt. But on top of it, one of the properties of sound, and more so of near ultrasonic or higher frequency sound, that it doesn't travel outside physical boundaries, right? So you must have heard about drive-by hacking and all that, which attacks your network from outside your house or outside your office space. You cannot do that with sound. In sound, you have to be physically present in the same room to be able to do that. And that's one of the big advantages here. Is to be able to access the system, you will have to be physically present. And that's a huge security add-on that is that's just added naturally through in the system.
Wow, yeah, that's really good.
So one of the things that we get a lot of questions is what about voice authentication, right? Because we all agree that voice is the future. It's rapidly becoming the user interface for devices that do not have a user interface. And it's expected to grow at a tremendous rate. The problem we see is that deepfakes or the technology for deepfakes are increasing at even greater rate, right? And it's becoming very easy to make deepfakes and fool many of these systems. So I don't know if you're aware that in December, there was a hack on a bank using deepfake that stole $35 million, right? Which circumvented the voice authentication system. And these are some of the reasons. That's why the PSD2, which is European Union's payment directive, does not allow voice authentication for banking transactions. Now, we do not suffer from these problems because one, we are not making any print. We are not doing any kind of matching. It's a real-time data link, and it can support. It supports multiple different types of encryption. So you can choose your encryption scheme, and the communication is one time, and the code, real codes are transferred. There's no matching. Which can, essentially, which can be hacked or which can be circumvented using deepfakes. So obviously, we talked about voice authentication, but the obvious question would be, and I think it came up a little while earlier, is what about other modalities? Why not use RF, right? And so on. So a lot of people are using RF, and some places they are a good fit. But if you look here, on top are all the modalities of authentication modalities, and on the left are the best case use cases where they're being used. So one of the examples is I'm sure, do you guys use Apple Pay or Android, Google Pay?
What we have here, we have something called Pay Me in Hong Kong, which is similar. It's an app within your device from HSBC. So
okay, good. Yeah. So probably it uses NFC, right?
Yeah.
And the thing with NFC is it's great for Android users because Android has access to NFC. Now, in Apple, it's locked, right? So, so only Apple Pay can use NFC in Apple for initiating a transaction, right? So a lot of apps are not able to do that. One, and second, NFC is also not present in a lot of devices. So, for example, in India, about 30% devices don't have NFC, so it's not as universal. Right? Voice recognition we already talked about. I'm sure you have heard about all the stories of like SIM jacking and SIM jacking, as well as malware that actually steal the text or SMS codes that you get on the phone. And BLE, Bluetooth for authentication. Bluetooth is great for lot of purposes, but for authentication, it's really very painful. You don't want to be stuck, trying to log into something and the Bluetooth would not work, right? And biometric, of course, a lot of places biometrics are still used, but as we all know, biometrics should never be, kept on a server because that creates a huge problem if they're hacked. Because essentially, you cannot change your face if that data is leaked. So we do not suffer from any of these problems. And we give a toolkit for people to use in whichever way they want to use this. We do focus more on like multi-factor authentication and IoT use cases, but the toolkit itself lends itself to whatever use case you want to use it for.
It's interesting. We started out on this journey thinking that solving the ease of setup problem would be the most important thing. And obviously it's a big stumbling block that people run into when they first get devices, so they're really aware of it. But our developers have been coming to us and saying, no, what's really important is this authentication part, because we really need to do secure transactions. And there are other companies out there who are using ultrasonic to do financial transactions, which is fine. There's a company in the US called Listener, and there's a company in India called ToneTag that's looking to make digital wallets, basically, so you can do transactions. But I want to point out that financial transactions have to be secure, but they're a very small sliver of all secure transactions, right? There's a reason right now that your browser says HTTPS at the top, because you don't want to be leaking your information all over the place. So we can help with both the ease of setup and also just authentication and security in the large sense.
Yeah, I think what Bhaskar said about needing to be in proximity in the same room, and then
proof
also
of presence is a huge important one.
Yeah, and not having this to go through a cloud where there's, the data is going somewhere else through someone else's system. I know that's a big issue with some of the Japanese brands, specifically in trying to introduce things like Alexa or similar. Is talking with Amazon and the concept of, are you collecting the data when nobody's talking to them, and the privacy issue for that kind of use. So this is kind of it eliminates that issue.
Right. So I think it's an excellent point, David. I think we need to reiterate it's always on the edge. So you can have the transaction could be completely offline. We only collect data which is not, so we don't collect any data, but even we are processing data, the data that we process is inaudible data, so above the human hearing range, and that data never leaves your device. So it's always on the edge, and your application has access to basically whatever data that you are sending.
So a few things I'm curious about. Do you need to control both ends, or is it standardized to the extent where, so if I'm just building a phone, I can just implement it and interface with whoever else has done it on their side?
Great question.
Yeah, great question. So in general, go ahead, Rob.
The receiver needs to have the Trillbit SDK in it. The speaker could literally be your web browser playing a pre-canned piece of audio, basically.
Okay. So it can actually be unidirectional. You don't on both sides. You don't need the microphone.
That's correct.
No, we don't need. Yeah.
A common use case, however, is imagine you've got two devices, your trusted device and your not trusted device. They both have internet connections,
yep.
right? But you want to authenticate the communication with the untrusted device. So, it can send, your trusted device can ultrasonically send a one-time pad to the untrusted device, and they can meet up on the internet and say, yep, that's me.
Sure.
And that's how you get the authentication.
So
it can be one way at the audio end.
Yeah. So I think here is I think that this example or this use case lends well to what Simon is asking. So in this case, Simon, is the bus use case where for transportation. So all the users have their phone, and that phone, the app has the SDK, but it's not they don't have a microphone access. So when they open the app and they say, yes, pay my fare, the app starts transmitting, and the device on the other end, which is attached to the bus or with the conductor, has a microphone, right? And that device has access to the microphone. So in this case, for example, they're just transmitting, and that's just receiving. They already have pre-shared secret keys, so the communication is still encrypted, but essentially they don't need to have two-way communication.
Excellent,
Right.
perfect. And then on more of the acoustic side, because I'm just curious. So obviously you can't be in ultrasonics because you're going to pass the Nyquist frequency of any digital system. So you'll be sitting around 20 kilohertz or as close as you can get to the air.
Yeah, so 17 to 21.
Yeah.
Right. So the standard CD was 44 kilohertz sampling.
Yeah.
And standard now digital audio is 48 kilohertz sampling. So technically we can go till 24, but we generally limit it to 17 to 21.
In full disclosure, my 11-year-old son can hear squeakies, so he can hear it.
Yeah.
I can just hear clicks.
Yeah. And so the microphones would generally be not a problem because they have pretty huge bandwidth, usually well beyond Nyquist.
Yeah.
But you have to take a bit of care with the speaker, would you? Because some of them could just really fall off a cliff when you get into the higher frequencies.
They do, but we had, and that's like some of the challenges on working with pre-existing system, like not having your own, proprietary hardware, for example. But we handle it through signal processing. So we can handle a wide range of devices. So that was we have, it works in over like 300 different makes and models, like, all permutation combination of devices. So the performance characteristic might be slightly different, but the minimum performance characteristic that we say, if it is 1 feet, that means it works till 1 feet for all different kinds of devices. When we say 20 feet, it will work till 20 feet. So yes, that is there, but we handle it through signal processing.
Simon, you have a bit of a signal processing background yourself, yes?
A little, yeah.
So me too, a little.
Yeah.
These guys, Bhaskar and his co-founders, used to work in the petroleum industry, where they would do seismic imaging of subsurface features using acoustic waves, right? And to decode the information you get back from the sensors is an incredibly complex problem. And this is what gave them the technical foundations for doing this kind of work. And if you really want to kind of geek out on the technology, the Trillbit technology has multipath resolution. It's immune to multipath interference. It handles Doppler shift. It has variable bitrate encoding, so you can choose between very fast at very close or with really high noise immunity at a long distance. Right. And it does all this with a very small coding footprint. Yep. So it's just, to me, it's just kind of totally awesome and wonderful what they've created here.
Very much so. And the actual SPL levels that you generally transmit wouldn't necessarily have to be that high, maybe 80 decibel type of levels.
No, it could be very low. And anyway, like, as you said, higher we go, most of these devices are tuned to work at like audible frequencies. So they don't produce the same amount when you go at like near ultrasonic between above 17 kilohertz.
Very cool. Very cool.
And so is the code is locked up in intellectual property, or how does the business come together for this? You license it out?
So it's basically an SDK, and then we have you can get a freemium version, and then based on the use case, we have a few pricing models for the SDK.
Okay.
So it's not a licensing model per se, but it's more like a pay-per-use kind of thing.
Okay.
Our one thing I like about the business model is for that the setup, it's per device. For the authentication, it's per transaction. So if a developer comes to us and says, "Oh, we want to do ease of setup," they get the technology, and after if they come back to us and say, "Oh, we'd also like to add authentication," that turns into recurring revenue for us.
Okay. And okay, so what else could we know here? So geographically, you guys are located in the U.S.
Boston-based company with a strong technical team in India. I happen to be in Los Angeles.
Okay. All right. And so then, like, how's the company growing? Is there FAEs coming to China or something for helping Simon and I with our projects?
It's funny. 4 months ago, I remember our presentation used to talk about what we needed to do next, and it was to move from a founder-led organization to a business-led organization, business development. You know, and in that time, we hired a gentleman named Benno Ritter, and he heads our BD group. He used to be an executive in the Zigbee Alliance. He used to work at Infineon, and to put it simply, he's the man with the Rolodex. We closed out our year 20% higher ARR than we expected to. Our sales pipeline has increased by a factor of 4 since he came in. So things are happening very fast. I give a lot of credit to Benno and his business development efforts, but it also seems like we've hit. It's funny. We developed this technology, the ultrasonic technology, several years ago. We did not anticipate how quickly voice-controlled devices were going to come to the market. And so it's been this confluence, this really lovely confluence of we have the technology and look, suddenly there's a real need for it. So this is why things are growing fast.
Yeah, and also we discovered you through your relationship with Knowles. So
great.
Being in partnership with those guys is a huge catalyst. Like the deployment of their MEMS devices is crazy, and then there's Infineon, AAC, and all kinds of others in that space as well. All right, I think that's fantastic information. Simon, did you have any other questions that you wanted to hit me?
Just scripture, even the SDK, we're talking Android. You mentioned Espressif. What other platforms is it?
So we have for Android, iOS, we have a web SDK, which works with most of the web browsers. And then we also have embedded Linux, ARM, and ESP32.
Okay.
So, yeah.
Very well covered then.
All right. No, that's a massive market. Just for reference, I like the geoseismic kind of roots of this. I come from a place that's oil heavy, so we can talk about that.
Where is that?
I got a place called Alberta, Canada.
Oh yeah.
Oh, of course.
Oh
yeah. You have the tar festival is that?
The festival.
There's a festival, right?
Oh, the rodeo, you mean?
Yeah. Like all funded by oil industry. It used to be. I don't know if it still is.
Yeah. I'm sure if you went there during oil industry time, it was a big party where they host all their business partners. But all right, let's not bore the audience with rodeo talk. All right. So everybody, please, we'll put the links to find out more about Trillbit in the description below. And so please like, subscribe, and share this around. This is a kind of a very exciting technology, I think, for IoT and authentication applications. So thanks everybody for watching, and thanks for Rob and Bhaskar for joining us today. We appreciate it.
Thanks for the opportunity.
Thank you.
You guys.
Okay.
And for the great
Thank
question.
you for having us.
Okay. See you, everybody.
Yeah, bye.